Hi everyone, welcome you all to today's very fast class. We are going to start a very simple topic. Okay, so I will tell you which topic we are going to start just in a few seconds, I can say. And my brief introduction is my name is Nirupama Mahapatra Das. I'm a PGT mathematics. You can say I'm a maths educator and I'm a passionate teacher and I am a Google certified trainer. So this is one of my, you can say, very small initiative to support the students community. Yeah, on regular basis, I will be posting recorded lessons. You can say video lectures and study materials, and within 6 months or 7 months, as we have planned, we will be finishing the whole NCRT. Okay, both the volumes. And of course, as I said, it's a very small initiative from my side to the students community. And obviously, we really want to help the students. Okay. And everything is free of cost. So you can feel free whenever you have any questions. Okay. And I already have written in the chat box and in WhatsApp group. Any query you can message either to me or Jyoti ma'am. Okay, so let us begin the class, and just let me share my screen here. Okay, so this is the topic we are going to start. Okay, so matrices and determinants. This is chapter 3 and 4 of your NCRT textbook. And this is from the unit algebra. And as of now, like I can refer to last year's syllabus, because for 22-23 we are waiting to receive the syllabus, though we are hoping 30% reduction in the syllabus. Okay, 99% it will be like that only. And again, for entrance exams, so conceptually one has to study in a very detailed manner. Okay, so now this is, you can say, algebra portion, chapter 3 and 4. Okay, in the unit algebra, we are covering chapter 3 and 4. So till this time, I mean till last year, you can say weightage of this topic is 8 marks. Okay, so if it is whole syllabus, like 8 marks out of 80, and if it is term 1, term 2, so again, you can say you know that. So basically, the weightage of this topic is 8 marks. Okay. And I'm considering out of 80 marks for the time. I mean, at this point of time. Okay. This is the concept map. We can start with, the topic is matrices and determinants. Okay. And it is covered in chapter 3 and 4 of your NCRT textbook. We will be covering what is a matrix, order of the matrix, types of matrices, matrix operations and their properties, or you can say matrix algebra, what is a determinant, minors, cofactors, and how to evaluate the determinant, singular, non-singular, and invertible matrices, and finally applications of matrices and determinants. Okay, so this is what we are going to cover in chapter 3 and 4. Okay, so today maybe we will be covering some portions, and from time to time you will be getting the updates and you will be getting the video lessons. Okay, so just to introduce the topic or just know what is a matrix. So how should we begin with? So let us consider a situation. Suppose you want to write your marks. Suppose you had periodic test 1, periodic test 2, okay, and you may take here, 2 tests, you want to write, summarize the marks scored by you in 3 subjects. So maybe one subject is physics, next subject is chemistry, and third subject is mathematics. Okay, so you want to just write it in tabular form. So maybe your score in physics, so we are considering since it is periodic test 1 and 2, so maybe we are considering the tests are out of 20 marks. Okay, so your score in physics may be 15 marks, and in chemistry maybe you are scoring 18 marks out of 20, and in mathematics you are again scoring 18 marks. Okay, in second this your score is maybe in physics you are scoring 16 marks, in chemistry you are scoring 15 marks, in mathematics you are scoring 19 marks. Okay, so now how to write it? We have written like this. Now if I write like this, I know this is PT1, I am taking like this, periodic test 1, periodic test 2, and I have taken the subjects like this. So if I write like this, I may enclose this within this bracket. So maybe I write like this: 15, 18, 18, 16, 15, 19. Okay, now if I just write like this, means after giving some space, okay, proper spacing I am considering here, and I am writing each entry and enclosing within this bracket. Okay, and basically another thing you can observe, I am writing like this. You see, periodic test 1. So this row represents periodic test marks in physics, chemistry, and mathematics. Okay, second row represents what? This is row. Okay, horizontal lines are rows. Okay, now here you see, if I second row, this I can say it is first row R1, second row R2. Okay, the second row represents the marks scored by that particular student in periodic test 2 in physics, chemistry, and mathematics respectively. Okay, now another aspect also here, this is first column, vertical lines you can say this is column 1, 15 and 16. Now if I consider first column, so the first column represents marks scored in physics in periodic test 1 and periodic test 2. Similarly, this is your second column and this is third column. So we can arrange the marks or arrange these numbers in this way. We can also arrange like this. Okay, this is called parenthesis. If I write like this, 15, 18, 18, 16, 15, 19. Okay, we may write like this. So while writing this, so you can see we are just following some sort of arrangement. Okay, we are arranging the entries, arranging the marks in rows and columns, right? So this gives us the idea of matrix. So then what is a matrix? Just let me. So the matrix is, yeah. So this, as I said, this gives us the idea of matrix. Now matrix is an arrangement of numbers or functions in rows and columns, or you can say it is an ordered rectangular arrangement of numbers or functions written within this bracket. Okay, this type of bracket, square bracket we may take, or we can take parenthesis. Okay, so basically it is an arrangement of numbers or functions. Okay, then how to write it? I mean notation. And what do we mean by whenever we write 15, 18, 18, 16, 15, 19? These are called elements or entries of the matrix. Okay, So it means, for example, if I write here, I am writing here 2, 3, 4, 1, 7, 9. Okay, so these are entries of the matrix. Okay, and if I write here, suppose this is A, this is okay, so matrix A is this, and the entries are 2, 3, 4, 1, 7, 5. Or I may write B is another matrix. I may write here sin x minus cos x, okay, cos x, sin x. Okay, so it may be like this. We can take any function. Okay, so basically, yeah, it is an arrangement of objects and rows and columns of a matrix. So as I just a few minutes before I said, rows are always, we go like this. Okay, columns we come vertically. So here this is first row, 2, 3, 4. Okay, they lie in first row R1. This is second row. This matrix has 2 rows, and this is first column. This is second column. This is third column. Okay, so this matrix A has 2 rows and 3 columns. And in case of matrix B, how many rows and how many columns? We can say sin x minus cos x in first row, cos x, sin x in second row. And if you observe, this is, you can see first column, second column. So we have 2 rows and 2 columns. Okay, so rows of the matrix can be written denoted by Ri, and columns we denote it by Ci. It means R1, R2, R3, like this. Okay, first row, second row, third row, and so on. Similarly, C1, C2, C3, first column, second column, third column, like this. Okay, so elements of a matrix or entries of the matrix is basically the numbers or functions within the matrix. The numbers or functions are called elements or entries of the matrix. Okay, now here you can see a notation also a little bit I told you. Whenever we write in matrix, you can see here A matrix 2, 3, 4, 1, 7, 9, we enclose them within this bracket. Okay, B matrix, again we have taken sin x minus cos x, sin x, we enclosed within this bracket. So matrix is denoted by a capital letter of English alphabet. Okay, and the elements of the matrix, elements of a matrix are enclosed within this bracket or this bracket. We do not have any third choice. Okay, here you can observe whenever we are talking about elements of a matrix. So you see, there are, you can say A11, A12, A1J, A1N. Okay, then A21, 22, 23, 2N. So like this. So I'm just explaining this. And rows, you can see the row means, you can see here the horizontal, I mean, this highlighted portion you can see. Okay, this is, okay, row, and you can see column. Okay, so rows and columns like this. Now whenever we talk about yeah, so any element, so let me just take a simple example. Suppose you have 2, 3, 4. Okay, the same example I'm taking 1, 7, 9. Okay, this is matrix A. Okay, we are using English capital alphabets of capital letter of English alphabet, and this is your first row. This is second row. This is first column, second column, and this is third column. Okay, now what about this? You see, this element is in the first row and first column. So it means it is element of first row and first column, A11. Okay, here 3, element in the first row and second column. 1, 2. So 1 denotes for row, I mean it's row index, 2 for column index. Now if we come here, this element lies in the first row and third column. So we denote like this. Similarly, this is second row and first column, element of second row, first column, element of second row, second column, element of second row, third column. So every time we write the element, no, we are writing like A, I, J. Okay, I stands for row index, I for row index, and J stands for column index. Okay, so it means whenever we write 8 to 3, it means what? It means element present in the second row and third column. Whenever we write 833, element present in third row and third column. Okay, 821, element present in second row and first column. Every time row index comes first, then column index comes next. Okay, so basically, so whenever you have to see the element, so you can just go back. A11, A12, A1J means element of first row, first column, first row, second column, first row, jth column, first row, nth column. Okay, similarly 2, 1, 2, 2, 2J like this, and M1, M2, MJ, Mn. So from here you can see we have how many rows and how many columns? We have, you see, A11, 1, 2, 1, 3. Just observe the first one. 1, 1, 1 means this is element in the first row. And 1, 1, 1, 2, 1J, 1N. Second component is varying. Okay. So it means how many columns are here? 1, 2, 3 up to like N number of columns. Okay. So each row is containing n number of elements. So let me take a simple example again. If I write here, suppose 1, 0, minus 5, okay, and 3, 5, minus 2. So whenever I'm writing like this, you can see this is first row, second row, okay, first column, second column, third column. Okay, here you see 2 rows and 3 columns. So whenever we say 2 rows, each column contains 2 elements, right? Whenever we say the matrix is having 3 columns, each row is containing 3 elements. Is it clear? So it means when row contains 3 elements, number of columns 3. When the column contains 2 elements means number of rows 2. And here 2 rows and 3 columns, right? So it means we have 1, 2, 3, 4, 5, 6 elements, right? So whenever, if it is like previous one, I can take sin x minus cos x, sin x, 2 rows and 2 columns. How many elements are there? Number of elements 4. Okay. Now if I write here 2, 3, 1, 7, minus 2, 0. Okay. So this matrix has 3 rows and 2 columns. So number of elements 6. So one observation is, if the matrix has m number of rows and n number of columns, number of elements would be m into n. Okay, again I'm becoming a bit slow here. 2 rows, 3 columns, you are getting number of elements 6, 2 into 3. 2 rows, 2 columns, number of elements 2 into 2, 4. 3 rows, 2 columns, number of elements, 3 into 2, 6. Okay. Similarly, if you take 3 rows, 3 columns, again number of elements would be 3 into 3, 9. If it has m number of rows and n number of columns, number of elements should be m into n. Okay. So yes, that is done. Okay, Aij. So Aij is basically symbolic. I stands for row index, J stands for column index. And we can take like this. We will take some questions from here also. Now next, order of the matrix. So what is order of a matrix? Okay, so whenever, so order of the matrix is basically having, so how many rows and how many columns the matrix is having. So order of matrix tells us about the number of rows and number of columns. Okay, if a matrix has m number of rows and n number of columns, then the order of the matrix is m by n. Okay, is m by n, but we read it like this. It is read as m by n. Okay, just like no, in case of rectangle, if length is 24, width is 18 units, so we say it is 24 by 18, right? Okay, so how to write it now? Yes, so here we can say this is of order 2 rows and 3 columns, 2 by 3 matrix. This is also 2 by 3 matrix. This is your 2 by 2 matrix. Okay. Okay, so now you see another notation is also there. So the matrix is having number of rows m, number of columns n. Okay, and we know Aij stands for the individual element of the matrix. So if I write here A, whose elements are Aij, okay, order of the matrix is m by n, means the matrix is having m number of rows and n number of columns. Then I will take the values 1, 2, 3 up to m, and because number of rows m. Okay, J is column index. How many columns are there? N. So 1, 2, 3 up to n. Okay, now Aij order m by n. So number of elements would be m into n. Okay, order of the matrix here, m number of rows, n number of columns. Here you can say number of elements m into n. So it means if you have m into n number of elements, then what can be the possible order of the matrix you can form? Okay, you can have m rows, n columns. You can have n rows, m columns. Okay, so let us consider those things also. Okay, so here just let us take a pause, discuss certain points. So if a matrix has n number of elements, then n may be prime or n may be composite. Just let me take this one. Okay, so you can refer to exercise 3.1 in the beginning portion. First question is in the matrix. So you are given the matrix. Write the order of the matrix. Just let me write the question here. It is exercise 3.1 because as per our plan, we will cover NCERT book. Okay. you are given a matrix. Of course, this matrix is given to be 4 by 4. 2, 5, 19 minus 7. 2, 5, 19 minus 7. 35 minus 2. 35 minus 2. 5 by 2, 12. Okay. Then here, root 3, 1. Okay. Minus 5, 17. So each row contains 4 elements, means number of columns 4. Each column contains 3 elements, means number of rows 3. So here order of the matrix is 3 by 4. Okay, the first part is write the order of the matrix. So 3 by 4 you can write. The number of elements you can count here, but you know the trick now. 3 by 4 means number of elements. Number of elements 3 into 4, 12. Okay, write the elements of, just let me take randomly. So you have to find what is a 2 1. Okay, what is a 1 3. Okay, so what is a 3 4. Okay, and what is a 3 2. So A21 means element of second row, first column. Second row, first column. So 35. 813 means first row, third column. First row, third column. It's 19. A34 is, okay, third row, fourth column, 17. Then A32 is third row, second column, third row, second column. That is 1. Okay, so this is the way you can find the elements. And in case, number of elements regarding that also. Okay, next one more question, like, so you can just, if a matrix has 24 elements, if a matrix has 24 elements, matrix has 24 elements, what are the possible orders? What are the possible orders it can have? Okay, possible orders of the matrix. Just I am paraphrasing the question. What are the possible orders of the matrix? So basically here the intention of the question is, if you are given 24 elements, okay, so, and you have been asked to form matrices. So what are the possible orders it can have? So whenever you have a number of rows m, number of columns n, the total number of elements m into n. So what does it mean? M and n are factors of mn, right? So similarly here you have 24 elements. We can find the factors of 24. So it means you can have 1 by 24 means 1 row, 24 columns, 24 rows, 1 column. Okay, 6 rows, 4 columns, 4 rows, 6 columns, 3 rows, 8 columns, 8 rows, 3 columns, and 2 rows, 12 columns, 12 rows, 2 columns. So these are the possible orders. I mean, you can form such matrices. Okay. What if it has 13 elements? Suppose now 24 is a composite number. Okay. Suppose you have the elements. If a matrix has 13 elements, then possible orders would be what? Possible orders Okay, so here you see 13 elements. As you know, 13 is a prime number. So how many factors you can get? Any prime number you can have one and itself. Okay, so you can have one row 13 columns or 13 rows, one column. Okay, so basically from this question, what I want to convey you. So if you are given the number of elements prime, then you can have suppose n, and n is a prime. So you can have n by 1 or 1 by n. These are the two possibilities. Okay, I mean order of the matrix can be. But if n is a composite number, so then you can see all the factors, like in case of 24, 1 by 24, 24 by 1, 6 by 4, 4 by 6, 3 by 8, 8 by 3, 2 by 20, 2 by 12, 12 by 2. Okay, 3 by 8, 8 by 3. So these are the possible orders. I think it is clear. Okay, so before we come to types of matrices, no, one more type, construct a matrix. One third type of question, construct a matrix A equal to Aij. In the order I can take 3 by 2, whose elements are given by, whose elements are given by, whose elements are given by Aij equal to I plus j by 2. Okay, so it means this is the rule given for us. Okay, the rule by which the matrix will be formed, Aij equal to I plus j by 2. Now, first of all, what you need to see? Order of the matrix. Just let me write here. Order of the matrix 3 by 2, 3 rows and 2 columns. Means first row, first column, first row, second column. So we have 2 columns. So stop here. Then second row, first column, second row, second column. We have 3 rows. So we have to come to third row. Third row, first column, third row, second column. Okay. So this is, I mean, like this, our matrix will be. So our matrix will look like this. Now Aij is I plus j by 2. So it means A11, it will be what? 1 plus 1 by 2. Okay, A12, 1 plus 2 by 2. Okay, so like this you can form, right? So maybe direct, let me write here. So 1, 1, 2 means 3 by 2. 2, 1, 2 plus 1 by 2. Then 2 plus 2 by 2. 3 plus 1 by 2. 3 plus 1, 4. 4 by 2 is 2. And here it is 5 by 2. Okay, so depending upon the rule given to you, you can, you can construct the matrix. The first thing you have to see the order. Okay, whether it is given 3 by 2, 2 by 2, 2 by 3, whatever. First, you have to decide how your matrix will look like. Then you follow the rule. Okay, there are, couple of questions in NCERT in that exercise you can try. Okay, so this is basically, how to construct a matrix if the rule for element is given to you. Okay, and also, so by this time we have understood what is a matrix. Okay, and the order of the matrix, how to denote the matrix, if we are given number of elements, how to construct, how to decide what should be the possible orders, and if you are given the element of the matrix by a rule, and how to construct a matrix. Okay, then next we will come to types of matrices. Okay, so as in the beginning we have taken, so the numbers or functions arranged in rows and columns. So basically it's rectangular arrangement of objects. Okay, rectangular arrangement of numbers or functions. So basically all the matrices are of rectangular, you can say rectangular matrices. But we can divide these rectangular matrices in various categories. Just let me write it here. Okay, so broadly we can divide the matrix into three categories. Okay, so first one we can say rectangular matrix, rectangular matrix. Just like no, in case of rectangle, length is not equal to breadth. Okay, so just let me come back. Square matrix, in case of square, length equal to breadth. Okay, and third category is zero or null matrix. Zero or null matrix. Okay, so rectangular matrix, number of rows not equal to number of columns. Okay, number of rows and columns unequal. In case of square matrix, number of rows equal to number of columns. Just as I said, in case of square, length equal to breadth. All the sides are equal, right? So whether you go row wise or column wise, you can get same number of elements. So here, number of rows equal to number of columns. Zero matrix or null matrix means all the entries are zeros. All the entries are zeros. It means, so all the entries are zeros. So it means you can write here, if it is 0, 0, 0, 0. Okay, or you may write here, it can be a rectangular matrix, it can be a square matrix also. Okay, all the entries are zeros. Okay, now here, so coming to this rectangular matrix, basically, okay, so I mean, some special categories are also there. So as we know, if we take 2 by 3 matrix, 3 by 2 matrix, okay, when number of rows, number of columns unequal, we are getting rectangular matrices. Okay, so like we have taken some examples, 2, 3, 1, okay, minus 1, 0, 7. This can be taken as a rectangular matrix because number of rows not equal to number of columns. Okay, this is 2 by 3 matrix. But sometimes no, if I write here, suppose 5 minus 2, 3. Here you see there are 3 columns, but we have only one row. So 1 row, 3 columns. Okay, so it means we can call such matrices as row matrix. Okay, I can just write here row matrix. So row matrix means matrix having only one row, but number of columns, any number of columns. Okay, any number, COL, I'm just writing shortcut way, any number of columns. Similarly, column matrix, the matrix having only one column, any number of rows. Means if I write here 2 minus 1, 3. So here you see 3 rows, but 1 column. So 3 by 1 matrix. So it means here we can define one column, but any number of rows. Okay, so this is about, yes, square matrix is number of rows equal to number of columns. Zero matrix, I just told you. The square matrix, a little bit elaborately we can go. Okay, square matrix is basically, yes, square matrix is the matrix having number of rows equal to number of columns. Okay, number of rows equal to number of columns. So there are some categories. We can have some category here also. Okay, so let me take here. If I write here A11, A12, A21, A22. Okay, this is a matrix, 2 rows and 2 columns. Or if I write here 2, 3, 1, minus 1, 0, 5, 7, 2, 1. Okay, 3 rows and 3 columns. Okay, now if I write here A11, A12, A13, A21, A22, A23. I'm writing in symbols 31, 32, 33. So whenever you write the matrix like this, no. So one thing you observe, here you see 1, 1, 2, 2, right? When these cases, no, the row index equal to column index. Here you see 1, 1, 2, 2, 3, 3, right? So such elements are called diagonal elements. Okay, diagonal elements. So square matrix has diagonal elements. Okay, your diagonal elements are 2, 0, 1. Okay, in fact, so you may have the question whenever you take the square matrix, I mean, you have this diagonal, you can have 2 diagonals. Okay, so here we can say this is main diagonal. Okay, we can say this is main diagonal. Okay, from left top to right bottom. Okay, main diagonal. Okay, where I equal to j. Okay, row index equal to column index. Row index equal to column index. Okay, I equal to j for diagonal elements. This is the identity of diagonal elements. The other diagonal, you can say it is 1, 2, 2, 1. So it can be taken as diagonal, but we do not consider it as diagonal element. We can consider it as secondary diagonal. Okay, but in your NCERT book, no, that concept, secondary diagonal concept is not there. So we are focusing on diagonal element means elements in the main diagonal. Okay, from left top to right bottom. Or you can say where row index equal to column index. 1, 1, 2, 2, 1, 1, 2, 2, 3, 3, depending upon the order of the matrix. Okay. Okay, so whenever we say square matrix of order n by n, or simply we can say square matrix of order, for example, I say square matrix of order 3. It means it has 3 rows and 3 columns. I can say 3 by 3 matrix, or if I say the matrix of order 3, means square matrix. Okay. So elements in the main diagonal and secondary diagonal. So there are some other categories also. Just before we wind up the class, no, we will go through that. Okay, so now, yeah, so there are some other categories quickly, maybe in another 5 minutes. Diagonal matrix. Okay, diagonal matrix is basically what? Diagonal matrix is the matrix whose diagonal elements are non-zero numbers and non-diagonal elements are zeros. Okay, diagonal elements are non-zero numbers. Like suppose I can write here 3, 5, 1. Okay, here 0, 0, 0, 0, 0, 0. Okay, so this can be taken as diagonal matrix. So diagonal elements, it may or may not be 0, but yeah, so basically non-diagonal elements to be 0. So we can say here DIA. This stands for diagonal, and I'm writing here 3, 5, 1. Okay, it means it signifies your diagonal elements. Okay, we can write here comma also, it's optional. Okay, so if it is 2, why suppose 1, 0, 0, 3. Okay, so we can write here it is a diagonal matrix 1, 3. Okay, like this. So here, so what we can see here, if you may have the question whether, I mean, these are, we can say these are not all 0. Diagonal elements may or may not be zeros, but non-diagonal elements should be zeros. In that way, no, your 0 matrix or null matrix, I mean, whenever you have squared 0 matrix, basically square matrix, but null matrix. So that can be considered as a diagonal matrix. Okay. If I write here 0, 0, 0, 0, it can be considered as a diagonal matrix. Okay. So any query you can ask me. No, I mean group. I mean personally you have to ask me, because in the group only admins can this thing. Scalar matrix, quickly we can go. Okay, this is diagonal matrix. Now scalar matrix is scalar matrix. So scalar matrix is one sort of diagonal matrix. Okay, but here the diagonal elements are equal numbers. Okay, so diagonal matrix whose all diagonal elements are same. Okay, so first thing we have to see, this is a diagonal matrix. Diagonal matrix with equal diagonal elements. Diagonal elements. Okay, so it means if I write here 2, 0, 0, 2. Okay, this will be a scalar matrix. Okay, or you can say A 0, 0, 0, A 0, 0, 0, A. Okay. Okay, this scalar matrix, so equal numbers. And so still we have to see, like whenever we have 0 matrix, if the diagonal matrix can be taken as 0 matrix, which is a square matrix, I mean squared null matrix, you can say. It can be a diagonal matrix. So then it can be scalar matrix also. So every diagonal matrix is a square matrix, but every square matrix may not be a diagonal matrix. Okay. Every scalar matrix is a diagonal matrix, but every diagonal matrix may not be a scalar matrix. Okay. And unit matrix, unit or identity, this has major role to play. Identity matrix, unit or identity matrix. So here, this is again a diagonal matrix. Okay, but here diagonal elements are 1, or you can say it is a scalar matrix whose diagonal elements are unity. 1, 0, 0, 1. Okay. So we denote it by I. I stands for identity matrix. Okay, now here 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, now here identity matrix of order 2, identity matrix of order 3. Okay, we will restrict ourselves to up to third 3, order 3 by 3. Okay, this is I equal to this, I equal to this. And in some books, no, I2 means identity matrix of order 2. Okay, identity matrix of identity matrix of order 2. Okay, I3 similarly identity matrix of order 3. Okay, so identity matrix of order n is denoted by In. Okay, I3, I2, you can say In. Now, triangular matrix, the last portion, triangular matrix will be what? Yes, so upper triangular, lower triangular, and so the last category we can say, this is not in NCERT, triangular matrix or triangular matrices. Matrix is singular, matrices plural. Okay, so triangular matrices, just let me write here matrices only. We can have three types. One is upper triangular. Okay, upper triangular. Next, lower triangular. Then third one is strictly triangular. Okay, upper triangular, lower triangular, strictly triangular. So what is triangular matrix? So you can say, just let me, let me go for upper triangular first. So upper triangular is basically a square matrix in which, quickly I'll write down a square matrix. Let me go for upper triangular matrix. Upper triangular matrix. So it is basically a square matrix in which all the elements, a square matrix in which all the elements below the main diagonal, you understood what is main diagonal, right? I, right? Or J, 1 1 2 2 3 3. Main diagonal are zeros. Okay, all the elements are zeros. Okay, so it means, so basically what you can write here in symbol, you can write Aij equal to 0 for whenever it is below, below this means here obviously 2 1 3 1 type of things, 3 2. So it is for I greater than j. Okay, row index greater than column index. For example, if I write here 1 minus 3 4, okay, and here I can write 0 5, maybe 2 I can write here. Okay, then 0 0, maybe 7. Okay, here you see this is diagonal elements, right? 1 1 2 2 3 3. Now this is your upper diagonal and this is lower diagonal. Okay, so for upper diagonal you are getting I less than j. Okay, 1 2 1 3, then 2 3, I less than j. And for lower diagonal you are getting I is more than j. Okay, so this will make clear here. Lower triangular matrix will be what? Lower triangular matrix will be here Aij equal to 0 for I less than j. It means if I write the same matrix 1, maybe I can write 1 0 0. Okay, then here I can write maybe 3, maybe 5 and 0. Okay, and here I can write minus 2 1 7. Okay, so in this case you can see here the elements upper this is 0. Okay, so lower triangular means this, a square matrix in which all the elements above the main diagonal are zeros. Okay, so you can just remember like this: lower triangular means upper element 0, upper triangular means lower element 0. Strictly triangular means what? Strictly triangular means strictly triangular matrix. Strictly triangular matrix you can write. Now I'm in a hurry, we just because the class is taking a long time. Okay, strictly triangular matrix means, again, it is a square matrix where the diagonal elements are zeros. If I write here 0, 5, minus 2, then I can write 3, 0, 5. Okay, then I can add minus 2, maybe 1, 0. Okay, so this is strictly triangular. So here Aij equal to 0 or I equal to j. Okay, so now next class we can have the comparison of matrices, how we can compare to matrices, and addition, subtraction. Okay, so I hope whatever we have done today, it's clear, though it is very basic and introduction of the topic. So I'm sure it will help you, because if the introduction is good and in details, the other things will follow. Okay, so thank you so much. And okay, just let me stop sharing.